Spiral progression in science, a new feature in the K-12 curriculum. A CEAP NBEC's Basic Education Summit held on February 20, 2012, headlined that K-12 will strengthen the science and math education. It cited the use of special progression in developing a spiral curriculum in science. Accordingly, such an approach will, first, avoid disjunction between stages of schooling. Second, allow learners to learn topics and skills appropriate to their development or cognitive stages. Third, strengthen retention and mastery of topics and skills as they are revisited and consolidated. Today, everyone is highly motivated and interested to try the adoption of a spiral curriculum in science and math education. Along with the implementation of K-12 program is the strengthening of science and math education. In comparison, in the learning areas, the proposed K-12 uses integration and content-based instruction in kinder, grades 1-2, uses spiral progression approach from grade 3 to 10. For senior high school, grades 11 to 12, it uses the discipline-based approach. The spiral progression. This design is one in which key concepts are presented repeatedly throughout the curriculum, but with deepening layers of complexity. Such treatment proposes to make students repeat the study of a subject at different grade levels. The concepts or topics are systematically reintroduced at every academic level, thus considering their development stages. The basic idea behind the spiral progression approach is to expose the learners to a wide variety of concepts or topics, skills, and attitudes that are deemed of continual concern of everyone until they are mastered. Then, they are revisited in a more formal way and are carried one step higher to a new level at the same time connecting them to other knowledge, thus ending with a broader level of comprehensiveness. As the learners continue upwards, new knowledge and skills are introduced in subsequent lessons, resulting in a reinforcement of previously learned information. The spiral curriculum concept was proposed by Bronner in 1996. In structuring a course, a certain prerequisite knowledge and skills must first be mastered, which in turn provides linkages between each lesson as the students spiral upwards in a course of study. This process became a strong support of a spiral curriculum model in the 1980s. The spiral curriculum design features an end stage of eventual mastery of the structure of a large body of knowledge. After a mastery of the initial topic, the students spiral upwards as the new knowledge is introduced in next lessons, enabling him or her to reinforce what is already learned. In the end, a rich, breadth, and depth of knowledge is achieved. The science curriculum in the K-12 curriculum presents concepts and skills in life sciences, physics, chemistry, and earth sciences. The concepts are presented with increasing levels of complexity from one grade level to another, following the spiral progression approach. Furthermore, the concepts from the four sciences are presented in an integrated manner, thus ensuring a holistic learning of the environment and well-rounded application of skills to real life. Example given in the Table 1, content of science from grade 3 to 6. In grade 3, the topics, characteristic of living things, parts and functions of living things including the human, animals, and plants. In grade 4 topics, humans, major organs of the body, care for them, diseases, animals and plants, terrestrial, aquatic, life cycle. In grade 5, stages of growth and development, development of secondary sex, differences in modes of reproduction in humans, animals, plants. In grade 6, the topics are human body system, musculoskeletal system, digestive system, circulatory system of humans, animals, and plants. As you observe, as the grade level gets higher, the level of complexity of the topic increases, but it is still connected and integrated to each other. The Learning Spiral. It is a curriculum design tool which will help develop concrete and practical thinking-centered lessons that make students' performances of understanding explicit. It may be used to structure an entire project which can readily fit into the regular curriculum and can help design thinking-centered lessons. The Learning Spiral is a curriculum design framework which will help science teachers construct lessons, activities, or projects that target the development of thinking skills and dispositions which do not stop at identification. Instead, facilitate implementation of the desired performance. Today, more than at any other time, science teachers are faced with the ultimate challenge of producing responsible learners who learn how to learn, access updated information, apply what is learned, and address complex real-world problems in order to be successful. The teacher's academic goal is to make students independent, lifelong learners. Bronner emphasized the gains that can be acquired by developing students' powers of analysis, judgment, and memory in order to increase capacity to transfer learning into new situations. His idea was the transfer of thinking process from one content to another required students to learn the fundamental principles of subjects and to explore ideas on a deeper level rather than just mastering facts and the role learning procedure. The spiral approach was compared to the traditional or sometimes called mastery approach. In the spiral approach, the students learns through repetition, that is, the topics are taught once and move on. The next lesson will review the previously taught concept as the new one is being introduced. Generally, a wider variety of concepts are covered, unlike in the mastery approach wherein the students mastered a concept in order to be able to do more advanced concept. They spend much time to master a concept before moving on to the next topic. Bronner believed the curriculum should revisit the basic ideas repeatedly, building upon them until the students understand them fully. And that is the spiral curriculum.